Okay, it should be any second now.
Got it.
We got it.
Okay.
Hello, everybody. Welcome into the SBAU Astro Hour again on our second anniversary, starting our third year of blog podcasting, a weekly Monday morning get together, 11 to noon, of the South Coast Longtime Astronomy and Telescope Club called the Santa Barbara Astronomical Unit, where me and the Brain Trust and other officers of SBAU, my name is Ron Herron, Vice President, ex-radio guy, your host for the next hour. We get together on Zoom from our man caves and computer rooms, kick around space news, and boy, we got a lot of it this week. For the week of, by golly, it's the 27th, next to the last day of February 2023 to the 5th of March. This hour, we're going to talk about a parade of planets, touch on Jupiter, and it's colliding with the moon, or possibly going to go behind it. We'll see if there's an occultation. Venus and others. Haven't been able to see them lately, and it's starting to rain again. Check out the story we missed last week about Perseverance on Mars and what it has dug up. We're going to look at 3 galaxies in the tail of Leo, the lion, and 4, count them, 4 incredible cutting-edge topics, if we can get to all of them. That mysterious, elusive Planet 9, my God, out there in the Kuiper or Oort cloud. What makes for heavier elements? They're not necessarily created in stars, probably not at all. Past iron. A voyage to the Proxima Centauri system. That may be in the agenda. I don't think we'll live through the voyage, gentlemen, but our kids will. Black holes and dark energy, is there a connection? And this Friday night, join us at Parent Hall at the Museum of Natural History, our benefactor, and his name is Raphael Cottom, and he is going to be talking to us about whatever this, well, I'll find out. Let me introduce you to the gang. President Jerry Wilson.
Good morning.
In white. Congratulations to winning the Santa Claus lookalike contest again this year. Over in front of the Ukrainian flag is our incredible outreach coordinator, Chuck McPartlin, who's also married to a Pat, as is Jerry, and Pat McPartlin, his wife, is our merchandise manager. With the permeating smell of sourdough bread in the oven, here is the former Westmont College science instructor, Tom Whittemore.
Morning. Got a good nose, Ron.
Yeah, and Maureen is his wife, and he's a very stalwart operator. But if he can, he'll set the scope up at night. And lately, you just haven't been able to, have you?
Right, yeah. I've been looking
for. But you can't see anything.
Yeah.
Oh, there's Bruce Murdoch, who's also president of the Theodore Orkin Society. He's married to Bonnie, and Tom is married to Maureen. And here we are, the 5 of us, going to kick these things around. However, we start things out with a little levity, get us all in a good mood, and there's some strange stuff that you're going to need to explain to me that was sent out by our president. That is a circular rainbow, the complete one.
Yes.
I don't think we can normally see, but I understand commercial airline pilots sometimes can. Is that possible?
This was taken from 30,000 feet out an airliner window.
Yeah, that's neat. Yeah.
It's a neat picture, so I just put it up there.
Wouldn't that be something? So the horizon has to really be low to give us the bottom of the rainbow. I wonder how many people would know this. Here we are. Every first Friday of the month, we macaques, orangutans, and chimps gather next door in the Gladwin Planetarium of the Apes to watch Madam Chrissy Cook's. That's funnier than hell. I love that. The Planetarium of the Apes. It's in Gladwin, next to the Fair Hall. That'll be this Friday night. Here are the Hell's Angles. If you ever wondered, there's the right angle, the obtuse, the acute. The president of the club is named Hypotenuse. Be careful of these guys. They'll corner you. Waiter, my soup appears to have an animal inside it. And the waiter, of course, from another planet, I guess Mars, says, yes, it's an eel. This is going to be a play on words, one of those Tom Whittemore puns. Eels don't look like that on Earth. He said, well, this is a Mars soup eel.
So I termed that a groaner.
Yeah, that's true.
Yeah. I don't get that one.
I'll give you another groaner at the end of this if you want. Mars is the only known planet inhabited solely by robots.
I like that one.
And if all those rovers that are rolling around decide to get together, we're in trouble. It'll be AI. Why science teachers should not be given playground duty. What is the name of this concept when the balls are equal on both sides? What is that called?
I don't know.
It's something from, I guess, Sir Isaac Newton, wouldn't you say? Maybe not, no?
No, it's just a clever toy.
It is. It's cute as hell.
I'll show you conservation of angular momentum.
All right, this one needs
Not
some
angular, linear
explanation.
momentum.
Yeah,
Let's say linear momentum.
Right.
how to
Yeah.
put a duvet cover on. What does this mean? You want to explain it, Mr. President?
Oh, one, you locate the corners. Line it up long way with the bed. Locate cover corners. Somehow
Rip.
find fifth corner and rip space time. Uh-oh. Call Neil deGrasse Tyson. Yeah, it happened again.
So what's duvet defined
Duvet.
as?
A duvet is just a cover on your bed.
Oh, I got
The
you.
warm blanket on top.
All right, that's funny. Okay.
And there we are.
Yes.
So,
All right, here's the other groaner. How does the man in the moon cut his hair? Any guesses? Well, I hear eclipse it.
oh,
Wow.
that's a reach.
I know, I heard it on one of the networks the other day. Well, we got some great stuff to talk about, but we haven't been looking at the night sky much. We can't really, but at least we're not frozen solid or having twisters like Oklahoma did overnight. My God, well, one quick question before we go to the sky, gentlemen. How do you explain to the deniers of global warming that all this incredible snow, they're going to say, no, it's wet, it's cold. We don't have global warming. How do you explain
They
that
don't
to
want
them?
to be, they don't want to have an explanation.
Yeah.
They're living in their belief shell and let them.
Well, why
Yeah,
would they-
what-
Ron, the fact that the overall atmosphere of the Earth is warming, that's an average over the entire planet. That doesn't mean you can't still get deviations in the jet stream that bring extremely cold air to other parts where you don't normally have it.
That plus the fact that the thing that drives storms is sea surface temperature. As the temperature goes up, you get more storms, bigger storms, and more frequent storms.
and colder temperatures?
For a while.
When
It
was the
averages
last
out.
time a blizzard was forecast for LA? I mean, give me a break.
1989.
So you think in the future we'll have warmer winters on average?
On average around the world, yes, but that
Yeah.
does not mean that some individual spot on the Earth can't have low temperatures.
Yeah.
Okay.
So I put this up because we talked about a tadpole star last week, and this is the tadpole galaxy. Someone mentioned that, but I didn't have a picture of it. So this is the other tadpole in the sky.
Losing in one of its arms?
No, this is just something that was ripped out from a passing galaxy that gravitationally pulled part of the mass out.
Okay. And is this a Webb telescope picture or the
No.
Hubble or?
This is a Hubble.
Okay.
Okay, well, last week we had a occultation of Jupiter.
Okay. By the moon?
Yeah, this is
Yeah.
the moon, and that little dot there is Jupiter. You can see it's getting closer and closer and closer. And if you go in real close, you can see little faint dots next to it. And there, those are some of the Galilean moons. And there I can see a couple. They don't
Is
really
that a
stand
full
out
moon or a
much.
new moon? Is that the last
This
of
is a
waxing?
crescent moon in the evening sky.
Means what? It's like
So it's
waning,
waxing
coming-
moon.
Waxing.
So it
Waxing.
means this is kind of flipped, depending.
Well, waxing means it's starting to fill up. Waning means it's about to close off.
That's
Yeah.
right. This
Which is it?
this is waxing.
Oh, okay.
But it's flipped one way or the other here because you don't
Yes.
normally.
Well, is it
This
also
was-
going to occult Venus?
This was taken from Argentina by an amateur.
Oh, no kidding. We couldn't see it up here
No, we couldn't.
because there's that much difference.
I think Jerry said it was Jupiter, Ron.
Yeah.
Yeah.
I know that, but is Venus, what's Venus going to do? Venus is in the news.
It's
Venus
gonna-
is going to be close to Jupiter. Here it is.
Very-
As a matter of fact,
Yeah.
here's Venus
Okay.
and here's Jupiter.
Mhm.
And this is going to be tonight, or not tonight, what is it?
Wednesday night.
Wednesday night.
Wednesday?
Yeah, 7:40 p.m. Eastern Standard Time. So it's 3 hours before that. So it's 4:40 p.m. here when they're
So
the
it's during
closest.
daylight.
Yeah. But you can see Jupiter and Venus during the daylight if you have a telescope with a go-to system, and you can just put the coordinates in and it'll go there. So I used to set my telescope up to look at the planets during the daytime because you could get good pictures because the sky wasn't in high contrast to the brightness of the planet.
Mhm.
But what I'd do is I'd set it up and looking at the planet in the nighttime, and then I'd leave it setting right there. And in the morning, I would, of course, Jupiter's moved in the meantime, or whatever planet I was looking at.
Mhm.
It's at the right declination. So I just scan in right ascension until I came across it.
Mhm.
Obviously, this is just above the ecliptic or on the sun's ecliptic, right?
No, this is just above the horizon.
Just above the
Yeah.
horizon.
These are on the ecliptic.
They,
Yeah, it
Plus or
wasn't long
minus.
ago, Ron. It wasn't that long ago that Venus and Saturn were in proximity.
Yeah.
well, where did Saturn go? Left or right?
Behind, it's on the other side now. It's going to be a morning object shortly, if it's not already.
Yeah. It's on the other side of the sun.
Quick question about Io, the dinky little dot next to Jupiter there.
Yeah.
It's an agony of lava and volcanoes because it's so close. Are there any other moons in the solar system that are as close to their planet as Io is? That's the only one that does this.
No, it
it's
isn't, Ron.
locked.
There are lots of moons in the solar system that have this tidal flexing, and it's not just from Jupiter. It's also from the other large moons. So that's why you have the cryovolcanoes on Enceladus. That's why you have stuff going on Europa.
And it segues nicely into the new technique that was published for finding Planet 9.
Okay, here we go. We're gonna
Because
segue.
Io glows by its own light.
Oh, it
because
does.
it is thermally active with the volcanoes and stuff. Because
Well,
of
also
the
it
tidal
gets squished
interaction
and
with
pulled
Jupiter.
it gets squished and pulled by the gravity of the large object that's near it,
Right.
and that causes thermodynamic heating.
Yep.
How can you compare cryovolcanoes, which is all ice and cold, with lava volcanoes?
Well, it's the same thing. It's heat, Ron.
Mhm.
And,
Really?
and these volcanoes on Io were predicted by a UCSB astronomer before they were found, because he figured out the dynamics of the large moons interacting with each other.
Yeah. But there's no other moon of the hundreds or however many we have in the solar system that looks like
92.
Io. It looks like a pizza. If you
Yeah.
look at the surface.
But those aren't lavas like we have here on Earth. Those are lavas made of soft materials like sulfates.
But they're thousands of degrees Fahrenheit, I would think.
No,
No,
they're not. They're not.
Well,
that
they
hot.
are. They are hot. It's the hottest place in the solar system outside of
Right.
the sun.
And
But it's not like the inside of Vesuvius or something.
Right. Well, yeah.
Yeah.
we don't have any plans to land on that one, do we?
Well, in Io, it's hot enough to melt sulfur because a lot of the volcanoes spew sulfur.
Yeah. And as a reason, as a corollary to that, you know why that's why sulfur is called brimstone.
Is it really?
You find it on the brim of volcanoes.
Fire
Oh.
and brimstone in the Bible is sulfur. Okay. Great picture. Great stuff. All right. So,
Yes. Fire and brimstone.
Yep.
all right. What do we got here?
This is a calculation. A
Okay.
fellow has proposed a method of finding Planet 9
Hmm.
Oh,
out in the Kuiper Belt or the outer edges of the Kuiper Belt.
If
yeah.
it has moons.
Yeah, provided it has moons. And he thinks that's likely because after all, Pluto has 5 moons. So things in the Kuiper Belt do have moons. The reason is that they're looking for this is they haven't been able to find the ninth planet, even though they can pin down roughly where it should be. It's hard to find. And so they're trying to find ways of enhancing how to find it. And just as you pointed out about Io around Jupiter, if this planet is something dark, like a black hole or a clump of dark matter, or just a real dark planet, it may have moons. And if it does have moons, they would be undergoing tidal friction because they are orbiting their parent body, and they would be just like Io. They would develop heat inside. So if you look thermally, and James Webb's telescope gives us that ability now to look out at these wavelengths, and you can figure out, you can see then that the moon would glow by its own light, and would be looking for something that's high temperature against the dark background of deep intergalactic space, which is about 4 Kelvin. So it would be a good contrast. And this is a curve for the eccentricities of the orbit around the planet 9. This is the estimated temperature fluctuation that you would see. So background of space is 2, 3, 4 is right there. So anything up here is going to be something that's going to look hot and stand out. So the idea is to look for the right type of temperature signature for small objects in the Kuiper belt, and they would be orbiting a dark planet 9.
So
If planet 9 is dark, and if it's there.
Try to find its own IO.
What's that?
Try to find its IO if there is one.
Yeah.
But
Hey, Ron, notice that the scale's logarithmic. Can I just notice that if that's a blue line, maybe it's black, it
Yeah, it's
crosses
black.
about room temperature, just roughly.
But now our previous vice president, whose place I took, was a young man from DP High School named Adrian Lopez, and he's down at Caltech, probably seeing Mike Brown, the professor who devoted Pluto and
Ron, no, he switched his major. He's doing particle physics now.
Oh, that's not Mike Brown. Oh my God.
No, this is big particles. But as Tom was just pointing out, this is 100 degrees Kelvin. Room temperature, which you are enjoying now watching this show, is 300 Kelvin, which is right here. So if this object could be generating enough heat, depending on where it is, enough heat to be at room temperature. You know,
Is Kelvin the same as Celsius?
it
similar.
is, except for an additive factor of 273 degrees.
Right.
It's over 3.15.
Yeah. It has the same scale, Ron, but it has a different kickoff.
Yeah, different start point.
So it's a little
Zero
like,
on Kelvin is absolute zero.
okay.
Zero on centigrade is the freezing point of water.
Oh, yeah, I know that. I know the difference between Fahrenheit, but it's like nautical miles an hour versus regular miles an hour. They're two different miles, aren't they?
Yeah,
Nautical mile is 6,040 feet, and a statute mile is 5,280.
Really? Now, why
So
would they
just-
have that? Is that the decimal?
Because a nautical mile is a fraction of the distance from the equator to the North Pole.
Yeah, it's based on longitude, latitude
Right.
measurements.
It's like difference
of a
between,
sphere.
it's like the difference.
So let
between-
me ask you a question.
Okay.
Does anyone happen to know the temperature where Fahrenheit and Celsius measure the same temperature?
40
Minus
degrees,
40.
40 degrees negative.
Yeah, minus 40 degrees.
Really?
Okay.
Yeah.
It's an old trivia question, Jerry.
Yeah, it is. Trivia, my dad used to have a phrase for that. He called them little known facts hardly worth knowing.
Well, boiling temperature in Fahrenheit is 212.
Yes.
Yeah.
What's that number on the Celsius scale?
100.
100.
100, see?
Yeah.
Yeah. And where does paper burn?
Oh, God.
Fahrenheit
451.
Fahrenheit 451.
Yeah.
Oh, that's right.
Great
There's a
movie.
movie about that. Yeah.
Twice boiling water. All right, we're back on Mars now, right?
Yep, this is Perseverance in the Jezero crater. As you recall, they picked where to land on Mars because of the mission of Perseverance. It's to find evidence of past life. And so they figure where there's water, there's life. And so they found a crater with a delta in it. And they thought if they land there, this place is going to be frozen mud or solidified mud or something. When they got there, the place they landed, Perseverance just went out and started digging, and they found that the rocks there were all volcanic. So that was a big surprise.
So it had water and lava.
Well,
Two opposite ends of the same.
And Ron, the bigger surprise was they found an empty bottle of vodka.
Some old Coors cans laying around. Well, they scraped on something that looked like crystal, shards of glass.
yeah, the broken up shard, that was the lava flow, hardened lava. So they
Okay.
so they went around the crater and they took samples looking for what would have been clay or mud in the past. And they pieced together from that journey, they pieced together a scenario for the history of Jezero Crater.
Hmm.
First of all, they said the basin has had flowing lava in it. And then it has had at least one lake that lasted perhaps tens of thousands of years.
Hmm.
It has had running rivers that created mud and sand delta. They eventually found it. And heavy flooding that brought rocks from far away locales and deposited them on top of all this mess.
Wow. Jezero crater is inside a bigger one, isn't it?
And I think that's the big crater.
Oh, Jezero is the big one. I thought your notes said it was inside a bigger one, but
Yeah.
and the river bottom just
Well,
never
here,
really had.
this
Go
is a
ahead.
picture
Huh.
of the sedimentary rocks that it found.
Wow.
Layers of sand and silt.
Over the millennia, lying. Wow.
Let's see here.
Ron, what you were thinking of was this crater is an area, a large area on Mars that's an impact basin. That's like a very, very large
Oh,
impact from the far, far
yeah.
past. So it's not really a crater. I mean, it's a crater, but it's not termed that.
Well, when whatever that rock was that crashed in, wouldn't it have melted a lot of stuff anyway? And is that a possibility where it got the lava, or melted rock from?
Could be some of it, or just
Impact.
stuff oozing up in the cracks afterwards.
Yeah.
I have another question about centimeters or metric. There's a little drill on this thing that's 5 centimeters across in a circle. How much is that in inches?
Couple.
Just
A
2
couple.
inches?
Yeah,
Okay,
a centimeter is just under 4/10 of an inch.
okay, got it.
0.3937.
Okay, and it's been drilling into these rocks and saving samples, 18 of them, I understand, and only half of them we may get back?
Yep. Well, no, we'll get to that.
Okay,
So this was where it landed right here, Perseverance landing site. Then it went down here to the first drill site, and it was expecting clay and stuff, but it found lava
Volcanic
broken
stuff.
up, and it abraded the Rocher rock. That was lava. So it came back up here to home base, and then it's decided to head for the delta, and it took this path around. So I guess
Scouted by the helicopter.
yes, yeah, that it had a scout with them. And so then this one arrives here at the Delta Front, and then Delta Front campaign went a lot. They went and dug into the stuff and found that there was sediment here. As of February 2023, this is where Perseverance is right now, and it's laid some of the samples that it was collected, 18 samples, as Chuck or what's your name?
Ron?
Yeah, Ron pointed out 18 samples. Over in the Delta regions, they found a lot of olivine, pyroxene, sulfate salts, carbonates, and feldspar by a spectrometer. And this is a scan of the soil there. Then this is a close-up picture of an olivine sample, which has been created. Olivine is made in the presence of water.
wow.
So they've got some good data there. And then this is one of the samples that Perseverance has pooped out. And it's been placed there gently, the article pointed out. So there are 18 of these, and they will be picked up probably in the 2030s, somewhere around that, late 2020s or early 2030s. And the speculation is that they had planned on using another rover to go around and pick these up from predetermined sites. But now they're planning on using a beefier helicopter. It's easier and more, you don't have to worry about the terrain, and it can get there faster. So it would load these up and put them in another return vehicle with a rocket motor on it and send them back up to orbit, and then they'd head to Earth in a vehicle that's waiting there.
We got a question from Tim. He's joined in, and he wanted to know what happened to all the water. And it's basically either been sequestered in the ice caps or in permafrost underground, or once the magnetic field went away on Mars, it can be dissociated by ultraviolet light and by the solar wind and blown away, basically. So abraded away by the solar wind once you don't have a magnetic field to protect you.
Well, have they found water underneath the ground?
Yes.
They
They
have.
found
Lots of it, yeah.
ice, and they
Okay.
have indications that there's water contained in salts or minerals.
Well, how do you make rust?
Well,
Yeah, that's all the
just
red color.
oxygen.
Yeah.
Fe2O3, you don't need water.
If
Yeah.
water evaporates into space, does it separate into hydrogen and oxygen?
Yeah, it gets dissociated by the ultraviolet light from the sun into hydrogen and oxygen. The hydrogen goes away first. The oxygen probably ends up in the rest.
Wow. Well, I got to tell you, gentlemen, if Elon Musk has his way, it'll be an astronaut picking that sucker up we're watching out right now.
Fat
I
chance of
think
that.
Elon Musk is way optimistic based on his
That's
past.
Ron, I
performance.
think what's going to pick it up is a red rover.
Yeah.
Yeah, a red rover.
Elon Musk is all over promise and under deliver.
Right. Maybe
Well,
we
I
can
know-
him
His
that.
cars.
The
I know
Teslas
some
work.
people- I know some people that bought his car.
Yeah,
Yeah, the car's nice. It's just if they could keep him away from the company, it'd probably be a lot better.
Well, yours haven't been recalled, have they?
Well, they call it recall for various things. They just do a software update over the air. So you're just
Oh.
parked in your garage.
turn your
and
car on and it says we've been rebooted or something, whatever.
Yeah,
You guys
So
can
you
now
know-
nap.
Elon did not start Tesla.
yeah.
Several engineers started Tesla, and they needed to grow. And this happens a lot with small startups run by technical people that have a brilliant idea.
Yeah.
They don't have business experience. They don't know how to grow a business. You can generally get a startup business up in the range of worth $5 to $10 million, and then that's where it stalls. You have to get a professional manager involved, but constrain the paperwork so they can't kick you out. And then from there on, it's a business prospect to grow it. And your brilliant idea is useful, but it's just the product.
Yeah. So Musk basically bought his way into Tesla.
Yeah.
All right. Well, you guys don't feel comfortable enough to sleep while your car's driving down the freeway, do you?
Hell no.
No, definitely not. I don't even take my hands off the steering wheel.
Yeah.
Whoa.
I've used his automatic driving a couple times, but I can't let go.
They got some videos you wouldn't believe.
I know, I believe him. I saw it.
Yeah.
Okay,
Here we go. Up to the sky. What are we talking about here?
this is the Leo triplet, which is
The Leo,
we're getting into the time of the sky, my favorite time of the year, because we're looking out of the north galactic pole of our galaxy. And so you can see other galaxies around. We're not, we don't have the Milky Way in the way. So one of the best things to look at is, there's a lot of galaxies around here, but the triplet is right down here, M65 and M66. And of course, that's two of the triplet. And it always amazed me that Messier couldn't see this third galaxy up here. This is M65
Hamburger.
and M66. And this is Thompson's got the hamburger.
Yeah.
Oh, it
It's
looks
got
more
a
like a
long-
hot dog.
Yeah. Not my
Okay.
club, Chuck, my old club.
So it's got a long streamer out there too.
Mhm.
So this is a well-processed image to show all the haze of stars out in the rim.
It's because we see
But
it.
I
in
guess
dawn.
Messier's telescope must have been very poor.
Well,
Mhm.
we're watching an edge on. The other two are full facing us, aren't they?
Not full. This one's tilted.
Mhm.
This is the most face on.
Well, I
Yeah.
thought Galileo's telescope's objective lens was like an inch in diameter.
Well, this isn't Galileo here.
No, this is
this
Messier.
is Chuck Messier.
Oh, okay.
I think he had 4-inch.
But the,
Right,
do,
Chuck?
the-
Between 3 and 4 inches. He had
Yeah.
one of each, I think.
Yeah.
do the three of these galaxies together constitute part of the constellation Leo? Is it like one
No.
dot?
No, oh,
No.
no.
Oh, it's not.
These are distant galaxies residing in the constellation, where the constellation appears. And they're easy to see in an 8-inch.
Yeah, can you go back to that configuration you had earlier, the last picture, Jerry? That is the lion looking upward.
Yeah.
Those are the legs. Okay. And
Yeah,
it's
you
got
see the sickle of Leo up above, going off at about a 45-degree to the counterclockwise.
Yeah. If you take this, and this away, is that right? Somehow I remember it as an arc going there.
Mhm. Yeah.
And that would be the head, and then not get rid of this. And then these are the front legs, these are the back legs, and this is the tail.
This is one of those weird constellation diagrams from H.A. Ray, where he made the lion have this little weird tiny head stuck way up there instead of the big mane and everything that you see in the classical constellation.
Yeah.
But
Now,
the-
Algeba is a really neat double star. I used to use that when I was testing my mirrors. It's also known as Gamma Leonis, Algeba. Beautiful gold double.
Yeah, it's right in the center. And Regulus, very prominent star
Mhm.
in the front of Leo. In 2017, if you were one of those that traveled to where the eclipse was total, I went to Oregon, Western Oregon.
Uh-huh.
You could see the eclipsed sun, and off to the side, you could see the star Regulus.
Yeah.
wow.
Yeah. I remember that in Greenville, South Carolina. That's where I was.
Okay.
And Chuck was in Wyoming, I think.
Yeah, Casper, Wyoming.
Yeah.
Well, I can't wait to see the cartoon version of the inside of our planetarium ceiling.
Oh,
Chrissy,
the new one?
is there a new one?
Well,
yeah, go ahead.
Well, Chrissy just announced that we got the new projectors. They're not going to go in till like the end of April, I think. End of March, maybe. And much higher resolution, much better dynamic range. So
But you can still throw all 88 up there, can't you?
sure.
Oh, easily.
All right, so this Friday night, you guys show up, 6:30, get to 7. We go in next door for half an hour at 7
No,
o'clock.
7 to 7:30.
Yeah, right. Always have fun. We always yell out in the dark. Okay, what is this?
This is an artist's rendition of two neutron stars colliding.
Aha,
A little bit fanciful, maybe.
Yeah, yeah.
we're talking about
There's-
heavier elements. Where are the heavier elements above iron on the periodic table? Where do they come from? Not inside stars, right?
Well,
Necessarily.
the large majority of them come from this more energetic collision between neutron stars. You
Yes.
still get the R process going on in supernovas.
Okay, well, the iron, which is what, 45 Fe,
Yeah, let's see, where is that in here?
26.
when it reaches iron in the process of fusing, that's the end of the star, isn't it?
Yes.
There it is, iron.
And doesn't it make them when it explodes? It makes the higher elements.
It
somehow?
makes some of them, yes, through this R process and something called the S process, slow process and rapid process.
Yeah, these would be made in an explosion, but these yellow ones are either all made in the neutron star collision because they require a real lot of neutrons. And these ones down here, so either partially or wholly due to neutron star collisions.
Well, how about a black hole? If one of them was a black hole, or if they're both black holes, does that put them out of the loop? Doesn't happen.
Well, stuff doesn't escape from that.
Yeah,
Neutron stars are the step right before black hole. It's
Yeah.
so crammed together that what, the protons and electrons become neutrons? Is that
Yeah.
how that works?
Yep.
Wow.
yes.
Yep. That's where big neutrons come from, Ron.
So
Thank
what
you.
happens? What happens? These pictures, these graphics are just excellent. They are from the January 2023 issue of Scientific American. Whoops.
Okay, geez,
And
radioactive nucleus, iron nucleus. Suckers
Okay.
are really tight.
so we start up here with neutron stars. They're made out of neutrons, need lots of neutrons. Now in a neutron star, or in the nucleus of an atom, of a stable atom, neutrons are permanent. They don't decay. But if you have a neutron in free space all by itself, it decays in about the half-life of about 15 minutes. So when the neutron stars, which are made out of neutrons, collide, you get all these neutrons thrown out all over the place. So they get picked up by the free neutrons get picked up by an iron nucleus, for example, and it'll pick up, it has in a stable form, it has 30 neutrons, but it's going to pick up a lot more neutrons, and it becomes a radioactive element. Now, these neutrons that it picked up in an unstable nucleus like this, these neutrons become protons. They decay from neutron to proton by throwing out an electron and a anti-neutrino, I think.
Sounds right.
Anti-neutrino?
Yeah, it's an anti-something.
It's not antimatter, is it?
Yeah, see, so it becomes extremely radioactive because of its lopsided number of neutrons. It's not stable. The number, to have a stable element, you have to have the number of neutrons and the number of protons the same. So some of these neutrons turn into protons with a lot of electrons given off.
And this is presupposing that there's some source of iron nuclei nearby. So maybe as a skin on the surface of the neutron star, or a cloud of stuff left over from when they exploded and became neutron stars.
But now the neutrons that are freed by the collision of the neutron stars, they don't just all automatically morph back into two, electron and proton. They stay neutron until they hit the atom, the iron atom. Is that?
No, it depends how long they're out there. This is a very dense atmosphere. If they're out in free space for more than 15 minutes, half of them have decayed. And another 15 minutes, half of those have decayed. So you're running out of neutrons. So it's got to have this absorption by iron nuclei fairly soon. And then inside this atom, neutrons start turning into protons until you get a balance of neutrons and protons. So how many neutrons you picked up and how many protons there are that it'll end up being defines the new element. And for gold, that's 79 protons and 118 neutrons.
Wow.
Yeah. Just a mention of Ron's, you see those little arrows that say beta particles?
Yeah.
That's what in the early 1900s, that's what we called electrons,
Yeah.
beta particles.
Well, now electrons are, unlike photons, which are pure energy, electrons have a little mass to them, right? Don't they?
Yes, a rest mass to them.
And they're equally minus to protons plus, even though I guess proton's a bigger piece of mass, maybe, I don't know.
Right, it would take about 1,800 electrons to weigh a proton.
But then are all neutrons out there and all the atoms in the universe defined as a combined proton and electron put together?
Hydrogen
Do they
does
all
not have any protons.
say again, Bruce?
Hydrogen does not contain any, neutrons.
Oh, it doesn't. Well, okay, but somehow when they get together, they become a neutron, right? The plus and the minus.
Well, helium has 2 neutrons and 2 protons.
Right, that's called an alpha particle.
Right.
Talking about
nucleus.
definition of the particle. I know there's quarks and things in there, but I guess it's all the electric.
That's a lower level than what we're talking about here.
I understand that, I know, but this whole thing about, there's also an element that we don't have time to get in called the weak force that has to do with radiation.
That's what's causing this decay here.
Yeah.
That generates decay, Ron.
Decay.
That's decay here, where these beta particles are being given off. That's the decay process.
Right,
This-
different from tooth decay.
Yeah.
Yeah.
This guy can overcome the weak force holding him in the nucleus. And that's how he gets out.
Yeah.
There's also a strong force in there. That's not involved, right? We're
Well,
talking
that's
about
holding them together.
Yeah,
Yeah.
that's holding the particles together.
Right.
And the
Like two
neutrons do give up their particles. So I don't know exactly the play of weak and strong force in this. I'm not a particle physicist, I refresh my memory, but it fades. So the idea is that you inject a lot of neutrons into a nucleus that has too few protons in it. And so then the neutrons are not stable in that situation. So they start giving off beta particles until enough of them turn into a proton that you have a balance between neutrons and protons again. And that gives you the new heavy element.
Well, the minute that happens, do you suddenly get an electron that's added to the shell orbiting around?
This is an electron, and the electron goes out of the nucleus. Whether it forms an atom or not, it depends on the external situation, how hot it is, whether the electron can stay captured to the nucleus or not.
Yeah, it depends on the energy level that these stuff flying
Right.
around has.
But eventually these nuclei pick up electrons.
Well, here's something that I can't understand. We all know that atoms are so small that it takes jillions of them to make even a sample we can see or hold. You know,
It's
then,
technical.
It
What?
takes 10 to the 23rd of them.
okay, are they all automatically turned into that same element?
Well, that's a
Together?
mole.
What?
No, he was talking about a mole. Avogadro's number is 10 to the 23rd, 6.023 times 10 to the 23rd.
That's like a standard amount of an atom,
Right.
Ron.
Right.
It's just hard for me to understand how all that teeming mass of different element atoms inside the colliding neutron stars
The atom is completely defined by the energy levels that the number of protons are in the nucleus. If the number of protons is the same in two atoms, that will be the same element, whether it's
That's
fully
their atomic
ionized
number.
or it has electrons or not.
Right.
But how can they all, billions of them, become the same? And we
They're-
get a layer of it back
They're
here on
not.
Earth.
And they become all sorts of different heavy elements in this case.
Mhm.
We just picked on
And
gold.
something that's stable.
Yeah.
Huh.
They do this process until they get to a stable condition where the neutrons stop decaying into protons.
Well, now there are some way high elements that we make, right? That don't get made, californium and
Yeah, those
fermium.
things, their lifespans are like very small parts of a second.
Mhm.
How
Yeah.
about,
Parts of a microsecond.
Yeah.
how about plutonium? Is it naturally made?
It has been seen naturally, but it's hard to make.
Mhm.
And it's very unstable. It won't last long. But in
It's
doing,
also very toxic.
yeah,
Anyway,
I've heard
so
that.
there is from spectral observation, there is evidence for this process in the form. Which element is this?
Strontium.
Strontium. I think that's right. I don't see it anywhere on this curve though.
Well, it's in the paragraph on the left. In the second paragraph down.
Oh,
up a
yeah,
little.
that- there it
Yeah,
is right
third
there.
sentence, third line down. Yeah, second
Yeah,
paragraph.
strontium, another heavy element.
And this is the spectrum of one of those kilonovas where you have
Right.
the neutron stars colliding.
Yes, and the thing that sparked this was so fun. One thing that sparked this was the simultaneous emission of the light and the gravitational waves from the same source.
Let's go in the same speed.
Yeah,
Haven't had a lot of gravitational wave success though, but that's what it would take is a couple
no,
of,
they see a lot of them. We just don't hear about it so much.
oh, is that right?
It's not a news event anymore. They just are working on them.
Well,
It's
what's
become a normal
they've got-
observation.
Yeah,
Well, they
they've
keep
got,
refining the gravitational wave detectors too, making them
Yeah.
more sensitive.
And
Oh.
getting more of them so they can do triangulation.
Yeah.
two in America, Washington and Louisiana, right?
Yeah. And one in Italy.
Italy.
Right.
But what you're saying here, Jerry, is that we wouldn't be here if a star didn't explode, and B, we had a colliding pair of neutron stars. And somehow they got together, or they became the same cloud that became our solar system.
right. Poetically, you can say we're made of star stuff.
Right. Thanks,
Well, I
Carl.
understand that, but what are the odds? You know, if it was just an exploding star, there wouldn't be enough elements left.
The odds of us being here are 100%.
Yeah.
We're
Right.
here. Okay. Is this something we can see? Does it make two colliding neutron stars? Is it as bright and
No, it's not as bright. That's why it's called a kilonova.
Oh, that's what it's called.
But they have seen optical counterparts for, I think, at least one of them,
Okay.
maybe more.
And when they do collide, if they're that close to being a black hole anyway, they become a big black hole a lot of times.
They could, or they could become a bigger neutron star if it's not near the limit.
Wow. Amazing stuff. They spin together, don't they?
Yeah.
They
Yeah, the
both
thing
have
that-
whatever spin they're left with from the previous life. And
Well,
as
the,
They can from measuring the gravitational waves, they can tell how close they are to colliding. You know, they can
yeah,
see the spectrum of the noise that's coming from them and see how close they are to actually hitting, because the frequency chirps up.
that artist pictorial of two neutron stars spiraling into each other bothers me because you have to conserve angular momentum. And it looks like they're coming in with one angle, one rotation like counterclockwise, but then they're going to orbit each other in a clockwise direction. That doesn't seem right.
no, all of the angular momentum of the final product is a vector sum of the angular momentums that were all there beforehand, the spin
Right.
of each object and the rotation of each object around each other.
Yeah, so
If
that's
they
why
have
those
the
artist
rotation
renditions.
So sometimes
we're
they add
going-
up, sometimes they don't.
You've really lost me on that ending, gentlemen, but let's go to Proxima.
It's called
Okay.
twice.
Dr. Lubin, I presume, right?
Yep.
He's mentioned in this article, but we have had a talk from him. He's got the most interesting name for his group out at UCSB, experimental cosmology. He's not going to sit there and look at things through a telescope. He's going to go get it.
Is it Phil? Is Phil Lubin? Jerry?
Yeah.
Yeah.
Yeah, I almost had him ready to talk to us and he canceled last minute. So he's a very busy man. And
He's a
they're gonna
very
do
busy
this?
man, but he's a great speaker.
Yeah, he's wonderful.
Yeah. So
And here's
anyway,
a-
this is an artist rendition of a sail-driven satellite called Ikaros, Ikaros. I don't recall what that means.
Well,
But
that comes from the Greek Icarus, who was the
Yeah.
guy who made the
Right.
wax wings and flew up too
Right.
close to the sun.
Yep.
Right.
so they
Phil
have
took-
figured out what they need to do to get something, and they have the target defined, the design envelope of what they need to do. And they're testing different aspects of this envelope. And one of them is the sail, the solar sail. In this case, when we send it to Proxima Centauri, we're not going to use solar energy. We're going to use phased array lasers to push it across, because we can push it way out there. And these things have to accelerate to about 20% the speed of light in a few hours or something, or a few days. I forget the number exactly.
I think it was even a few minutes. It was incredible.
Yeah. This whole thing is incredible, but our technology, it needs technology advances to go. So anyway, here's the phased arrays, lasers.
Mhm.
And this is the solar sail that they plan on using. And at the center, there will be a camera and a transmitter. And that camera and transmitter, well, now that it's all small and fuzzy, there's a weight limit on it.
Seems unpredictably small.
Yeah, unpredictably right. Each light sail would be limited to about 1/30th of an ounce, less than 1 gram.
Wow.
And has to be incredibly reflective. And the nanocraft attached.
It's going to be able to transmit from 4.5 light years away.
It has to be on the order of a gram. So
They can't transmit from that far away because they have such a small antenna, but all they have to do is talk to the next one in line,
right.
and they can bucket brigade the data back.
We're not going to send one, we're going to send a whole stream of them. So by the time the first one reaches Proxima Centauri, there's a whole line of them all heading that way. So they
And all of
bucket
them-
brigade back to us.
All of them will have receivers and transmitters so that they,
Yeah.
They are the repeaters.
wow.
And right now we can make cameras the required size and capability, but it only has about a 200 by 200 pixel resolution. The target is to get it up to about, what is it, about a 14 megapixel camera, somewhere in that range. Then they'll figure that the camera will be okay. In the talk we had one time on this topic, there was also a biologist that talked about putting a tardigrade in a life capsule on one of these things to send it.
Oh, yeah.
A what on board?
Tardigrade.
Tardigrade.
What's that?
Those are
It's a
those little
little-
water bear creatures ended up on the moon accidentally here.
Yeah,
Gotcha.
they're
Well,
everywhere.
I don't think Dr. Sagan would have liked that, polluting another planet if it landed on Proxima B. But so there's going to be a whole slew of these. And is it an array of lasers or just one big?
No, it's an array of lasers, so they're phase locked. When you put them together in phase lock, it overcomes a lot of the problems that lasers have. When you fire through an atmosphere, the atmosphere disperses the beam, and diffraction of the aperture disperses the beam. That's overcome when you do these, when you phase lock these beams together, like a phased array radar for receiving signals, but this is sending out the signal. And they stay coherent over very long ranges. So it's been speculated that they can stay coherent over the diameter of our galaxy. I don't have any corroboration of that. I just heard that phrase from one talk I was at. So,
Or we could all just stand outside at night with our laser pointers, those green ones.
Not
laser
coherent.
pointer. Yeah,
They're coherent, but they're not phase locked.
yeah.
Oh, they're not. Well,
These
that's what
phase
I'm wondering. How
lock
in the world do
lasers.
they zero in and know where the damn things are? They're too small to see, aren't they?
No, these things will be quite big. They'll be several inches across. Matter of fact,
No, I'm
here's
talking about once they get going to hit where they are. I know it's
they'll be farther away. Here, this shows one as being 13 feet or 4 meters high and 4 meters
Ooh.
wide.
Okay, and
That's the sail part. The chip
Yeah,
part
that's
is
the
just a
sail
tiny
part.
bit in the center.
Yeah, there's 25 millimeter spacecraft in the middle. This little orange dot right there's about 1 inch on side, like a postage stamp. So
so
there would be,
even though light is has no mass or
It
therefore no
does
weight.
run.
rest-
E
no rest
equals
mass.
MC squared. Light has energy, light has
I
mass.
totally understand that, gentlemen, but it's always pushing on us too. If we go out in the sun, we get a little bit of pressure. We don't feel
Yeah.
it, but somehow there's pressure with light. Or we
There's
talk about-
momentum, yeah.
you
Right.
wake up with a hangover and you're going to feel the mass of pressure.
So
So,
Ron, you
yeah,
ever play with the radiometer? You ever play with the radiometer?
No, what is it?
It's a small instrument I used to show all my students that basically exhibits momentum transfer from photons to little, panel. And it twirls around like a weather vane. It's really neat.
It looks like a little light bulb. It's got an evacuated glass bulb, and then there's a little black and white thing in there. And as the light comes in and reflects off of it, it imparts momentum and it starts to spin.
yeah.
I
Right.
thought they came up with a new theory that it's more that it's the black side that ejects the, what residual gas is in there, and that's the momentum that causes it to go around, because it goes around the other way, doesn't it? From where the
Right.
white area.
Black
So
side
it's very
trails,
important.
yeah.
It's very important that not be a pure vacuum inside.
Right.
Yeah.
Have residual gas in there.
But one thing that comes up that we didn't discuss specifically, but that is that light doesn't have a rest mass, but it does have momentum.
Right.
Yes.
And momentum is a vector. And so you can push on it and you get a direction that way.
Mhm.
The energy is contained in the electron, in the photon itself.
Mhm.
The photon. But it stops on a dime and lands in where? An atom and gets resent later?
The photon reacts with the material that you have.
With electrons.
Yeah, with the electrons. And depending on the electronic structure of the material, it either bounces off or gets absorbed and re-emitted. So That's the details of the interaction of light with matter, which is a separate torus usually, or
That's
unit.
all the quantum stuff.
yeah.
Right. Yeah.
But this is still all in the theory stage, right? What we're watching, they don't have a planned launch of these things.
No, there's no plan, and there is funding for this. So far, it's this is a picture of a hypothetical picture of being pushed, and there's a satellite that is larger, but a concept. This is a conceptual drawing, or this is a artist rendering of Proxima Centauri system. And Proxima Centauri has 2 planets shown here as.
They're only showing one here, and then there's Alpha and Beta way in the distance there.
Yeah, this is Proxima, and this is Proxima B, and Proxima C is not shown anywhere.
Yeah.
So let's see if they have the. No, this is something else. But I have down here that
Proxima B is in the Goldilocks zone that might have life.
It's only an approximate drawing, Ron.
Well, I
Yeah.
understand that, but is this the one we're looking at that could have life?
Yeah.
Yeah,
Depending on how active Proxima B,
Yeah.
Proxima itself is.
it could have life because we don't know anything about really what's required. With more than, so it's got over $100 million in funding so far, but it's estimated that it will take about $5 to $10 billion to develop the process here and the technology and launch it.
Wow. 20% the speed of light.
Mhm.
That's still booking, you know, you'd think it would run into some dust particles that would annihilate each one of those.
That's why you send a whole bunch.
Yeah,
Mhm.
Well, if any one of them goes down, there goes the link in the communication chain.
no, the link is massively parallel. You
What
know,
does that mean? I don't understand.
You have a whole bunch of them, a whole cloud of them, Ron, not
Yeah.
just a single line.
each line of things heading for Proxima Centauri has a lot of buddies all at the same point. And one of them gets taken out, the rest of the line continues forward.
And yet something that small, duplicated many times, is going to have a powerful transmitter and receiver and a
Not
battery.
powerful, no, very, very low power.
Yeah,
That's why they
powerful
use
enough.
many of them, yeah.
Look at the signal we get from interstellar space with Voyager 2 and Voyager 1. That's
true.
incredibly faint.
Yeah.
It's a very low data rate.
Well, I'm already getting scary videos on YouTube that say they're seeing the city lights on Proxima.
No, they're speculating that it's something to look forward, but to look at or to look for, but they've not seen.
They're already claiming, Jerry, that Webb has found the lights, and we just got to
Yeah,
be welcome.
Send me
crazy
the
people
article.
everywhere.
Exactly.
Send me the article.
Stay away from YouTube, Ron.
Yeah.
What is this? Which
It's a
galaxy?
This is the next topic.
We've
But
got
we don't
3
have time
minutes.
to get into it because we got 2 minutes here to go.
Right.
Right.
And that would
So-
be what?
We'll
This
do
is
that
the
next
black
time.
holes and dark energy.
Yeah,
I have some exciting news, and I was just curious if Chuck was copied to the email out at Westmont. Did you get a copy that there has been a proposal from Wayne Rosing's group in Las Cumbres to make the Westmont telescope a robotic telescope? Have you
Oh,
heard
I
that?
hadn't heard that, no.
I'll send you the email, okay, Chuck? Because you
Okay.
should know about this. And I think Wayne's idea is to turn the 0.6 meter telescope into more of an outreach vessel. And he wants it to join, of course, his system of telescopes.
He has the
I
one
just
that,
got it the other day, Chuck, and I was sort of surprised you didn't get it. So I'll send you that.
okay,
really
yeah,
interesting.
he's got the one out there at Sedgwick.
Right.
And, also, I guess they use the Falk scopes in England and in Australia. Like
Right.
I know Galita Valley Junior High used to use them.
Yes.
So-
Yeah. And all part of outreach, and educating kids. It's really amazing what Wayne can do, what Wayne does. It's amazing.
Well, our May speaker is going to be from Las Cumbres, a young man named Joseph Farah. The director out there, Sandra Seal, is sending him. And it looks like it's just our ugly pictures on the screen, gentlemen. I learned a lot. I always do. I just wish I could hold on to it. Damn it.
Mhm.
You guys take care of yourselves and your dogs and your,
Jerry. Good notes.
particularly those telescopes. Make sure they're polished and warm and don't look right into the sun. All right, gentlemen?
All right.
Give my love to your
Okay.
wife and let's do it again. Friday, we'll see you at least online or at the Fair and Hall, okay?
Fair and Hall, yeah.
And then we'll meet back here for number 106 next Monday morning of
Yes.
the SBAU Astro Hour. Bye, everybody. Thanks.
Bye.